Good afternoon, everyone. This is Dr. Snehal Mishra, Assistant Professor, IABMI. Welcome you all in this second session of second day on sampling techniques. So I once again invite Dr. DHandapani, sir, for delivering the lecture, sir.
Okay, thank you. So let me start from where I left. Okay, hope my screen is visible now. So I left you with a problem of finding out to estimate their traveling time. I will be taking it a little later. We'll continue that example. So before we move forward, if you have followed my lecture, you would have seen that I talked about the different the steps involved in it, and we'll stop at different types of sampling methods where we stopped. So now the next question is, the next step in a sampling design is, how do you estimate the population parameters or population quantities? So how do we do that? We need to construct a valid estimators. And I also told in the morning session that we need the estimators which are best in some sense, that with the less sampling error or less standard error. So that is what we need to do. And most of the time, the estimation or estimators are very simple. It is the sample analog of population quantity to be estimated. For example, suppose you are interested in like say average traveling time. So I want to estimate what is the average traveling time of the employees for the entire population of employees. So the estimator in this case, most of the time it is going to be the sample mean. The sample mean means particularly if you are going for SRS or simple random sampling, it is the sample mean. You calculate the traveling time for your sample, and that would work as the estimator for your population mean. So same way, if you are talking about proportion, say for example, how many are coming by a particular mode, say by car, own vehicle, or public transport, then in that case, how many in your sample are using that will be the estimate for the population proportion. Only thing you need to understand is, if you are going to, suppose I'm interested in and the total time spent on traveling by the employees, so it is not average, I'm talking about total. In that case, what we need is we have to estimate the sample mean from the sample observation, and then you multiply it by the population size. So suppose you are 1,000 employees, you calculate the sample mean for all the 1,000 employees in your sample, say whatever sample you have collected, and then multiply it by 1,000, you will get the total time spent on traveling by all your employees. So, but in case of a stratified design or multi-stage, then you'll have to build up from stage by stage. Basically, what we do is we need to take each sample value will be weighted, kind of weighted mean we have to use, and that weighted mean is inverse of probability of inclusion of an unit in the sample. So in what happens in simple random sampling is, it is very simple quantity. So it becomes easy, and it results in the sample mean for population mean. But in stratified or say multi-stage with unequal probability, then you'll have to calculate this inversion of a probability of inclusion. So basically what this weighing means, suppose you are 100 farmers are there and 10 farmers you are selecting, the probability in, say, for example, simple random sampling, the inclusion probability is 10 by 100 or 110. So what we are, and 1/10, you will be, what we are trying to do here is in the estimation is, it is something like one farmer value is representing 10 farmers. So that 10 farmers, so 10 sample farmers will represent the complete 100 farmers. So this is how it works. Of course, the expressions will become a bit more complex once you have a multi-stage, stratified multi-stage random sampling. But nowadays there are softwares which are available. So if you know how to, what are your weights and weights, how to calculate these weights, they are also available. So once you have, then everything, you can use those software to get the estimates as well as the standard error. Because estimation is much simpler, but when you go for a standard error, the formulas will become much more complex. For example, maybe you might have studied sample mean, and then its standard error, usually sample mean, standard error of, or the variance of sample mean is sigma square by n, that you might have studied in different statistical courses. So for example, if I want to estimate a population total in using simple random sampling, my the quantity I'm interested is the summation of all the y values or whatever sample values I have taken. I mean, and that all population values, that is the quantity y I want to estimate. The estimator, as I told you, that you from the sample value, I may have, say, small n observations are there. You calculate the sample mean and multiply it by the sample, the population size, that is n. The variance, the term which is coming extra, that is this quantity. This quantity is coming because of this capital N, but this quantity which is coming extra, this is usually the variance of a sample mean, sigma square by n. That is the usual formula. But if you see that, if you are going for a simple random sampling, and that too without replacement, this extra quantity is coming. So in fact, if you carefully observe these, this is nothing but you can rewrite this by 1 minus small n by capital N. So it is, you are, if you see here, the sigma square by n is reduced by some amount. You are multiplying by a fraction. So that means the variance will reduce due to simple random sampling. But if somebody was asking if population size is very large as compared to sample size, if n is very large, then what is going to happen is whether you multiply by, say, for example, small n by capital N is coming 0.01, 0.01. Then in that case, it is you are multiplying by 1 or you are multiplying by 0.99. So the reduction is going to be very, very less. So for a very large sample, whatever you are having, sigma square by n kind of formula will work. But if your sample size or the small n by capital N is not negligible, then in that case, you will have to adjust this. This is what we call it as finite population correction. N is missing here, finite population correction. Okay. So typically you don't have to remember or don't have to know about this formula, but the reason why I little bit put on this stress is that when you go for a survey, many things what we do in traditional statistics will get changed. So this has an implication when you use a survey data for certain data analysis. I'll come at the end what kind of things you need to keep in mind when you go for, say, for example, you want to fit a regression or you want to go for that, then what are the things you need to keep in mind? So let me come back to this step, that example which I was telling you, that the organization wanted to estimate the traveling time or average traveling time to work by their employees through a survey. Now, if this is our problem, this is our problem. Now, let me go through the process how we are going to conduct this survey. Suppose if you wanted to take this as a problem, through a survey, then what are the things we need to do? So it becomes clearer to you that what are the things we need to consider. Now, so before we start, we need to decide or identify or find many things. So like what is target population, size, whether we go for a census or a survey, what are the parameters to be estimated, how do you measure it, what kind of survey method you will follow, whether you will go for a questionnaire or something like that, what is your frame you require, how do you go selection method or sampling method you do, then what will be, how do you estimate the sample size, then finally what is your, how do you use the, what will be your estimator and the standard error. Now, let us first let us understand what is our target population. So the problem is clearly saying that our target population, we want to find traveling time from whom? We need to find the traveling time for the employees. We need that for employees. So which means that our target population is employees. So that is clear. But you need a little bit more clarity. So what do you mean by an employee? So because employee is a very general term. So when you go and start thinking about it, so whom I'm going to consider, then so many questions will come. So who are considered as employees? Can you consider, say, a consultant who is coming to you once in a month? Are you going to consider him as an employee? Or a contract worker is coming almost every day? So will you consider that contract worker as an employee? So you need to have a definition for whom are you considering it as employees? Because this, when you complete your report, the report has to clearly say that you cannot simply say that average traveling time by employees. So naturally the people will ask, who are your employees? So the one way is you can set up, you can define something like that, a cutoff date. Okay, I consider those who are on our payroll during, say, August 31st, 2020. So they are, and maybe for the last 6 months. For the last 6 months or last 1 year, who are on payroll for the complete 1 year, who are there, those will be considered as the employee. So all these things will matter when you are talking about creating a frame. So you have to be clear about it. So if you say, if you restrict yourself on payroll, then payroll may vary from month to month. So you need to be ready for doing some work for constructing the frame. So for that purpose, spend some time thinking about how do you define your target population. And again, when you are, depending on what you are estimating, what you want to estimate, suppose, say, for example, there are people who will be living in official quarters. So do you want to include them or do you want to exclude them? Because including them will change the value which you are going to obtain, because they may not spend more time. They may be spending maybe 2 kilometers. Maybe they may be going, I'm talking about a large campus, but they may be spending only 5 minutes. But a 2 kilometer person who is coming from outside of your campus may be spending 20 minutes. So it is, so you have to think about it that, okay, we will be talking only about the people who will be coming from outside, So you can exclude them, but if you include them, your estimates may go wrong. So these are some of the other issues you'll have to be clear about before you proceed. Now, what will be your population size? In this case, it is very easy. You can get it from the administrative record or the office records you can do. But in practical surveys, it will be, again, it will be very, very difficult, because sometimes you may not get it, though, so you may be estimating it from another quick survey, or maybe using projected values from some other studies. Somebody might have estimated it as an offshoot of something else, and you may have to use it. So, but typically what happens is, in with respect to population size, even if you do not know exactly what it is, still you can work on it, because many of these things will be for the you will be looking at the averages proportion, sample proportion. So for that, you don't require the population total. So the population totals are, the population size is required only when you want to estimate a total for the population, for the entire population. So anyhow, that is going to be a projected value. So you can use it, whatever is, assuming that this is my population size, then you can put it. But otherwise, you can restrict yourselves to averages or the proportions. So leaving out what is the total, people can estimate it on their own, assuming or whatever their idea about the population size. Now, in another thing, important thing in any survey is that even though the title or something may say that this is our major objective, this is our objective, but the project or you will be interested not simply for one information, you will not go for a survey. So any survey will have multiple objectives. So on multiple parameters you need to estimate from the survey. And moreover, when you are going to invest this much time and effort, naturally you will be tempted to add more things, because for analysis, why it is so. So you need several variables, several parameters you need to estimate. So traveling time may be one which we may be interested in. That is our major objective, but there could be many things. For example, again, traveling time, you need to define what you mean by traveling time. Is it coming to the office or going back to the home, or it is a total travel time? So that you have to do, and that is one thing. But again, you would like to know that, okay, traveling time is okay, but at average speed, so you want to calculate average speed at which they are coming, I mean average speed at which the traveling is happening. So for that, you need to have a distance travel, and people would be trying to understand that, okay, how many people are coming within 2 kilometer radius, how many are coming within 5 kilometer radius. So people would like to know info from your survey. So you will be adding many such kind of parameters. Then, like mode, what kind of mode people are coming? Are they coming by public transport, private transport, what they are doing? And also maybe whether they are coming directly to the office, or they're spending some time to drop off the kids or spouses. So all these things you will be doing it. So all these things, each of these is considered to be a parameter. So in any survey, you will be listing out, okay, these are the things which I'm going to get it from the survey. So and some of them will be profile of these people, all these things. So all these things you need to list out that these are the things which I will be collecting it, and I have to compute them. So because these are the one which will go into your schedule or into your schedule or a questionnaire, it is going to be there. Now, another important thing in any sample survey is that many times, so even though we may say that, okay, the travel time of our employee, then but quickly people will say, okay, I want to understand is there any gender wise, is it available? Whether the estimates are available for male and female, is it available? Or by category wise. category wise. So, and somebody was asking about what do you mean by a representative sample. So naturally, if you don't consider these different, these are basically called a domain, which is basically a subpopulation of interest. So if many time in many surveys, people would be interested to have this information, whatever information you are going to project it for the entire population, that should be also available for these subpopulations of interest. It could be gender, it could be employee category, or it could be anything. So if you know already that these are the domains, then again, people will say that, okay, I need to estimate it with certain level of precision at a subdomain level. So in that case, say for example, if you don't consider it, and if you try to create estimate for gender or employee category, it may be possible that say 98% of your sample, it turned out to be male, and only 2% are coming out to be female. So naturally, that kind of sample is going to be affected by this kind of bias. And this can come randomly, it is coming and you have selected it randomly. So everything looks okay, but when you construct this and the number of sample based on which you are estimating it for the domains of interest, uh, that precision will be affected by this low number of sample size. So you have to also identify, okay, up to which level I'm going to project these estimates, whether I need only projection or I need to estimate them with some kind of precision, with a minimum level of precision. This is again will affect how many, what will be your sample size. Now, if you think about the problem which, okay, so these are domains. So we need to be clear about, sometimes the domain will be also your stratification. So that way you can take care also. So next question comes is that, how are you going to measure these? So we said traveling time. So how are you going to measure it? So in this, we may seek direct answers from the employees. So we may ask them, okay, how much time it will take you to reach workplace from your home and returning. So in minutes, something like that, you can put it. So this is how you are going to measure it. But you can also see that, okay, because sometimes it is normal, sometimes in peak traffic. So do you want to have a separate estimate for a normal day, which is the usual time which takes, or sometimes peak traffic time, how much time it takes. So these are the things you need to, because see, once you decide, once you run the questions, once you fix this questionnaire or schedule, and you have collected the data, and then you cannot go back and get more information. So you will have to spend more time on how are you going to collect it. Again, this measurement, so what will be the time frame will you be asking? Will you be asking, okay, in the last 1 month, will you be asking, or for say last 1 year, are you going to ask? So all these things you have to keep in mind when you are framing your questionnaire, and that is what you calling it as the measurement process. So this is how we are going to measure. These are our variables. These are the ways how we are going to measure it. So through these type of questions, will it involve some kind of, then again, all kinds of other issues, something like, say, whether it is a sensitive questions, how do you ask these sensitive questions? So many things will come, but in this case, there will not be much issue. So all these measurement process, again, you will have to take care before you proceed. Now, how are you going to execute this survey? Will you be sending the questionnaire? So when you are thinking of sending a questionnaire, then you need as addresses of all the selected people. So it is going to, again, you need to have the cost built into your survey. So postal, and then how will you follow it up? All these things will be there. Then, if you are talking about questionnaire, then what is the mode? Will you be sending them? If they don't respond, what will be the follow-up mechanism? So all these things you need to do. Or you may think of that, no, I will go and execute a interview with a structured schedule. So the third option nowadays, which is very popular, is online survey. So, but all these things, again, it is going to depend on what is your expected rate of response. Typically, what happens is that in many surveys, particularly if you are going to execute it to where literacy rate is very high, particularly in developed countries, what they do is first they will send the questionnaire and wait for it, and then maybe again one more questionnaire, and whoever is left out non-response, then they try to follow it up through a telephonic, or they go and do the interview. So it is not that you have to fix it with a simple one way. So you need to, depending on what kind of responses you are expecting from your the target population. So based on that, you can do it. So, and you need to have all these strategy in place. Now, so we have decided about how we are going to execute this survey. So now the next question comes is that before we go for a selection of sample, we need the frame. Frame is the list of, in this case, it is a list of all employees. So as per our definition, we need to create this list, which is very easy in this case. But in real, this one, the up-to-date frames is very, very rare. For example, as of now, the complete list of villages in all over India is the only list you can think of is 2011 census. So that is about 10 years, almost 10 years old. And now that list, the problem is that even district list, if you see that the districts are getting divided and new districts are being formed. So all these things, so even at the administrative boundary level, you will have issues. Then you can think of at a much lower level. Of course, the statistical agencies, they have their own frames. Even they have something like a household register. All these things are there, but they will not be sharing with anybody. So that is how it operates. Now, how are you going to do? If you have any difficulty, then you need to prefer a multi-stage. That is the only way you can reduce the effort required to create a complete frame. So at last, what we need is that only at the last stage you need the frame, so that you can go on to the selected unit, say village or anything. Then you start building up your frame before you select the last stage unit. So this is how we need to go. And in this case, it is very, very simple, because you have list of employee records from the administration, you can get it, or administrative records, you can get it. So there is no issue. But other regular, this one, you will have that. These things will be there. Now, what kind of sampling method we can think of for this survey? Of course, simple random sampling is possible here, because we have the complete information, the complete list is available, or even you can get it very quickly. So we can simply go for simple random sampling. But you can also think of, suppose I want to have a better estimate for better than the simple random sampling. I can think of stratifying by say offices, because if you are having multiple offices, then you can think of the office wise. People may be asking, if suppose, for example, the company or the institution is located at different places. So if you are talking about employee traveling time, It may vary from one city to another city. So maybe your variability will be high. So you can stratify it based on offices. You can also think of employee category, because you may feel that within an employee category, like for example, say a supporting staff or somebody else, they may be using public transport, most of them, so they may have a different traveling time involved, or say somebody who is having in high income, high salary group, so they may have their own mode of transport, so they will have a different. So variability, if you club all of them together, then variability will be high. So you can divide them. Again, gender also. So in what way you can do? So you can stratify it. You can stratify it with the multiple parameters. So whatever way you can do. But if you are thinking of a multi-stage, maybe you can think of a category of employees will be one, that will be your strata. So maybe like maybe in government setup, A, B, C, D, group A, group B, group C, that kind of category exists. So you can use that kind of category, or whatever may be the category of employees, say management, top management, middle management, and operational workers, or something like that. You can have these kind of category, and or you can have category gender. That is, for example, group A male, group A female will be one. That is like that you can form. So all these things, say 4 categories are there, 2 genders are there. So 8 individual stratum will be there. So this is how, but if you are going for this, then you need to have in your frame, you need to have not only the employee name, their what kind of, which group they belong, group A, B, C, or D, male or female. So all this information is required when you are going to create your frame. Otherwise, it will not be possible. Then second stage, if you decide upon, say, category or category gender as your stratification variables, then the next stage, next one is, what is your first stage? Say maybe you can, if you have multi-city or multi-offices, you can consider offices as the first stage, and then within the office, so you suppose if you have several offices and you want to select few, then you can use first stage as offices. But if you have only say limited number of offices are there, then unless you don't want to select them all of them, then you go for sample. See, if you put anything, any unit in the stages, then only part of them are getting selected. Because you are going for a sample, so only a sample of offices will be collected. So this is valid only when you have large number of offices. But you have only 3 or 4 campuses, then in that, are you going to collect information only from 2 or 1? So how you are going to do it? So that is how you have to decide about whether to have offices as a stage or not. The last one is the employees. So that will be the employees. Or you can forget about offices. You can have stratification variable as category gender, and the first stage will be employees. Within that, each strata or category gender office is your stratification, and the first stage will be employees. So in that case, it is stratified single stage sampling. If you are going for office and employees, then it is stratified multi-stage. Now, how you are going to select the offices? You can go for simple random sampling, or you can go for, say, unequal probability sampling. Depending on, for example, here you can think of unequal probability in terms of how many employees are working in these offices. So some offices may have 1,000, some another offices may have only 10. So you can select the offices depending on how many people are there working in that particular office. So you can go for unequal. Otherwise, you can treat each offices as equal. Then you go for simple random sampling. Then employees, you can now in the last stage, it is always advisable to go for equal probability sampling, because we have taken care of variability at various stages. So the last stage, it is better to go for the simple random sampling, because that will uh, ease your way of constructing your estimate. So this is how you have to decide about how we go for the how do you decide whether you go, how do you decide your sampling method. So several things you need to consider before you arrive at one particular sampling procedure. Now, for the estimation, I'm just showing you for, suppose if I go for only simple random sampling, so the quantity I'm interested is the traveling time of each employee, average traveling time for each employee, that is the population quantity for all employees. But what will be the estimate from the sample? You take the average, individual traveling time in your sample and divided by your sample size. That will be your estimate for your population quantity of average traveling time. So this is how we move over. Now, the last question remains is, how do you select or what will be our sample size? So again, as I was explaining to you in the question and answers session, the sample size is going to depend, the major criteria is going to be what is the variability of the characteristic you are studying. So in this case, you have to think about that, how this average traveling time will vary across people, so different employees. So variability means that we are talking about variance of the traveling time. We are not talking about average traveling time, but we are talking about variance of traveling time. Suppose something is, say, 2 hours is say 80 minutes is the average traveling time. So how far individual will vary from this 80? So that is what we are thinking. It will, but the problem is that it will never be known. We don't know average itself. So how are we going to find out what is the variability? Now, another one is that what kind of sampling design, or in case of experiment, it is experiments, what kind of experiment you are using. In survey, what kind of sampling method you are going to use, you want to use. Again, that is going to affect your sample size. Now, the another way to look at this, people will be talking about, because sometimes we may be interested to detect some differences, because not only we are interested in estimating the population quantity, but we wanted to test whether some difference exists between different types of employees or employee category, gender, or anything. So we are not only interested in estimating, but we are also interested in testing certain hypotheses. Then in that case, what is the power of the test you want to do? What is the difference you want to detect? And what is the margin of error you want to do? So I will give you two ways. One way is how do we determine the sample size based on the variability of the characteristic study. And the second one I will show you with respect to the proportion, that how we can determine the sample size based on either margin of error or the power of the test and other things. Now, with respect to variability, so the variability is usually measured by the standard deviation or variance, but standard deviation will be on the same unit as that of your the parameters of interest or whichever variable you are doing, because the variance will be square, the unit of variance will be square of your original unit. So in this case, for example, if you are measuring it in minutes, so variance will be minute square. So it will be difficult for you to understand some value in minute square. So it is better to use the standard deviation. Or you can the problem with the standard deviation is that it is still dependent on the unit. So you can also think of that, can you express it in terms of coefficient of variation? Because coefficient of variation is standard deviation divided by the mean. If you are expressing it in percentage term, it is sigma by x bar into 100, otherwise sigma by x bar. So the CV, the idea of CV is that it is free from unit. So that means you can think of comparing it across variables, even though they are having a different unit of measurement. But the biggest challenge in estimating the sample size is that it is unknown. You cannot have this value is not known, because if you are knowing this value, then naturally there is no need of going for a survey, because if you know the standard deviation, it implies that you know what is the mean, right? So in that case, so how do you do it? So there are two ways. One, usually how many statistical agencies does is, or in any study how you have to go for is that if you have conducted any previous survey, then on similar lines in similar area, then you can try to understand that what is the standard deviation people are reporting. But again, that is going to be a chance, and purely by chance you have come across some survey, and that survey a reliable survey, and also mimicking your own situation, because a survey conducted in US or some other place cannot be used as something which will be applicable to our condition. So, but the other way is that you can go for a quick pilot study. So I will come back to that, how we go about it. But the first thing, the most important thing you need to understand is that if you expect variability to be high, then the sample size required will be also high. Just a minute. Okay. Why? No. No.
If they are asking from outside,
Our
you want to configure mail server, mail SMTP services.
But it is from our server only it will go. So there is no issue. We try, but I'm in class. Otherwise, you can configure it. It is not going to. It is from the server. The mail will go. From server, mail will go. Right. So it is not. Nobody outsider will not use it.
From
server it will. Okay. Sorry. The most important thing is that if you expect that there is going to be a higher variability, then you require more sample. If the variability is expected to be less, then the sample size required will be less. Now, how or from where this we are going to estimate is, again, as I told you, that it is going to come from the variance based on the selection procedure you are using. For example, if I go for simple random sampling, the one for the sample mean, this is our the variance of sample mean in case of simple random sampling without replacement. So here, suppose instead of variance, I can divide this by the sample actually this should be capital Y, the population mean square. This is population variance and this is population mean square. So the square of the coefficient of variance will be something like this. Now, if you see here, you are having the population coefficient of variance, sample size used, population size, population variance, population mean. All these things are population quantity, right? So only thing we may know about is this n. N is what we want to find out. So in this equation, CV is not known, S square is not known, Y bar square is not known. So only quantity which we may know is this capital N, that is the population size. This also sometimes we may not know. Now we want to decide about N. So one way to address this question is that, okay, what is our desired coefficient of variance, or the square of the coefficient of variance? So in that case, if you solve this equation for N, this is the kind of equation you will get. So this is population coefficient of variance square, and the same quantity but multiplied by the population size, and this is your desired CV. So we can fix this because this is our desire of what will be what is the desired CV we want. But still this quantity is still sitting in this equation to solve for the sample mean. So how do you, now the first question I will try to answer is, what will be the desired coefficient of variance, CV? So typically, what is the CV people use is that some of the agencies, statistical agencies, because the estimate which you are going to produce, if it is having high CV, then that results are, it is not unreliable. So usually some of these, of course, depending on the statistical agency, you will find again, they vary from 4%, 5% to up to 10% or so. So typically this is something like a basic thing they use is, say up to, if it is less than 10%, if any survey you conduct and CV of the important population parameter, estimated CV, is coming less than 10%, the estimates are considered to be highly reliable. 10 to 20% is acceptable, and more than 30% is unreliable. See, another thing is, in any survey, you may have several parameters you want to estimate. So typically, you can fix only for one parameter, because this, if you see in the previous equation, this is the population variance or population mean of a particular characteristic. So maybe I can fix this N for say average traveling time. What about distance travel? So a distance travel will have different population variance and different population mean. So that will give me a different N. But if I fix this N for average traveling time, then that may be having higher CV for some other parameter, maybe distance travel or something like that. So that's why for the parameters, at least the target parameters which we want to achieve, at least in any survey, you can identify that there are 2 or 3 important parameters we want to estimate it. So we need to consider their CV as the guiding force to fix the sample size. Because once you can fix sample size for all the variables, not for individual variables. So you need to fix only for one. So if your results CV is more than 30% for any of the parameter, then it is considered to be unreliable. But as I was telling you, that we need this quantity. We need this quantity. This is nothing but the population CV value. Now, how do we get it? So the only way is, as I was telling you, that you can think of looking at the similar surveys conducted in the similar area, and then find out what is the CV they are reporting, and then use that here. The other way is that you can quickly run a pilot survey, because anyhow you want to test your questionnaires. So go for maybe 10, 15 people, and then go for a pilot survey and get the, for that pilot survey responses, you can quickly find out what is the sample mean and the variance. And then from that, you can find out what is the CV, and then you can plug in that into this formula and you can get it. So I'll show you, and there are sample size calculation tools are available. I will just show you in R. This function is very simple. Basically, that is the same function which we are using, formula which I showed you, that one only, but the formula which I showed is for simple random sampling. So, but if you are going to use a stratified unequal probability or whatever it is, then the sample size formula will be difficult. So in that case, you can use these two. Now, this is a function. I don't know whether you know R or not. I'll just tell you that in R is something like Excel, you have functions. In R also you have function. So there is one package called practools is available, and in that we'll be calling this function. Yeah, this even you don't have to load this software. There are multiple ways you can run a R code in online without installing yours. If you are interested only to estimate the sample size, you can use this function. So this function is going to ask two things, or rather three things it is going to ask. One is, what is the desired CV you want to achieve? So you can either give it in terms of CV, or you can even give in terms of variance. But CV, what desired CV you want to achieve will be easier because it is free from unit. You can say 10% I want to achieve. My estimated value, CV of my estimated value should be less than 5% or 8% or whatever it is. So that is better because it is independent of what kind of parameters you are doing. If you are fixing it in terms of variance, then you have to think in terms of the corresponding unit. So CV is easier to use. The second one is what I was talking to you, what is the gust value of population CV. So that is either you go for a very quick survey and get this value and plug in into this. And the third one is, which is an optional parameter for this function, that is population size. So if it is not available, you can leave it and it will be assumed large. So I'll just show you, maybe at the end, I will just show it on the software, but I say in this example, say I want to estimate what is the sample size for average travel time. So that is my parameter. So let us assume that there are 500 employees are there. As I was telling you that it is immaterial, you can even ignore it. But what we need is, say, suppose I want to fix the CV as 4%. That is, CV is 0.04. Now, the last one I need is what is the population CV. So for that, I need average travel time and standard error. So I can run a quick survey, test the questionnaire also in the same way, and then I can calculate what is the estimate of average travel time and standard error. Based on that, you can calculate the CV and then get this value. Suppose, let us say it is coming out to be 0.45. This is just I just entered few values and then found out what is their CV. But of course, 45% CV is very, very high. But let us say I put it as 45%. So what should be the n? So I just ran this function. So CV0 is nothing but the value which I fixed, 4%. This is my population size. And this is what I got it from the pilot survey. So of course, this is a very large CV. So if you have such a large CV, naturally your sample size is going to be more. So when I run this function, so it gives me something like 100. or 101 as the sample size. So that is something like 20%, 20% of your population, right? So if your value CV is 45% and of the population CV is 45%, you want to achieve in the samples, the CV should be 4%, then the sample size is 101. On the other hand, suppose I relax this condition. Say I can say that, okay, I'm okay with up to 10% CV. I don't require my estimate should be CV should be at 4%, but I relax this to 10%. Then the number of sample comes down to 20. So it is all going to depend on this. So even if I remove this n as 500, then at 4% I require something like 126, and if I at 10%, it is just almost no difference in the sample size. So the trick is how you are going to get this value. That is what you have to worry about when you want to do it. Of course, this function provides you for different sampling method. I have shown you for simple random sampling, stratification, stratified random sampling, in the sense that you have stratification and every unit, within every stratum, you are applying simple random sampling. Then it is called stratified random sampling. So in that case, you need to, instead of the population size, what you are going to have is stratum size, and you will be giving 3 CVs for, or how many stratum are there, that many CV value you have to give. So you will get it. And for other designs also, other sampling designs also, you can get the sample size. So, so this is one way of estimating the sample size. The other way is, particularly this is useful sometime if you are thinking ahead, what is the margin of error you are interested. Again, this also will require the standard deviation. So, so what is the margin of error you want to fix? So basically, the difference between a standard error and margin of error is, the standard error is only by, it will be having the sample variance divided by something, but in margin of error, you will be attaching some table value. Margin of error comes from something like what is called as a confidence interval. So the confidence interval, you may say that it is 95% level or 99% confidence interval. So it is related to both. So the margin of error you have to fix, you can say that only 2% or 5%. That is a typical value people use. Sometimes you might have seen in some of the surveys, they will say that the margin of error in the survey is 5%. That means they fixed the sample size with 5% as margin of error. Now, let me put this margin of error thing in a different kind of parameter. The parameter which I showed you earlier is average or mean, sample mean. So what about, suppose I want to find out what is the adoption rate of something, some technology or whatever it is. So adoption rate is a proportion. It is not a mean. It is out of this many, how many have adopted. So that is a ratio or a proportion of having certain characteristics divided by total number. So this is what we call it as a proportion or a population proportion. Now I'm just showing you how to calculate the sample size for a population proportion. So the population, for this, what you require is 2 things you require. These 2, you can fix it. What is the margin of error? You can fix it at 2% or 5%, whatever it is. The level of confidence, you can put it as typically 95% is used. That is the confidence level we use, so there is no issue. or you can go for 99% also. Now, the third thing which is required with respect to any proportion, for that matter, for proportion, what you require is what is your guess of the adoption rate. So again, this will not be no. This will not be no. So you can use, if any previous survey has been conducted, then you can use that as a value. But if it is nothing is available, you can assume that it is 50%, because that is the symmetric value. So you can assume it at 50% and hope it will cover. For example, now in this pandemic, people are looking at what is the infection rate, how many people are affected by COVID. That is the true rate people are interested. That is also kind of proportion. That is also kind of proportion. So proportion, if you are in your parameter of interest is proportion, then it is very, very simple. You can quickly calculate the sample size. So what you need is only the current level or the idea about the rate or the proportion. If it is not available, you can straight away go for the as a P as 0.5. Suppose if I put 0.3, then I can this Z alpha is nothing but the normal table value at the alpha level of significance. So you can put it as you can solve these. So it is coming out to be 1.2, say 1291. It is coming. But the issue here is that why it is coming so high is that you are assuming that 30% only is the 30% farmers are only adopting that, and you want to estimate that true value with 95% confidence, and the margin of error should not exceed more than 2.5%. So if you increase the margin of error, this will drastically come down. The sample size will drastically come down. Now, these are the two ways I told you how to estimate the sample size, but there are a lot of other issues will be there because whatever I showed you is based on one single parameter. So, but as I was telling you in the earlier also, there will be several parameters which will be of interest. So which one you will take? So naturally, you will have to have, you may either have to estimate the sample size for different parameter and take the highest one. But that is again, it is going to take more understanding about the population parameter. So the other one is, this is one part, like we are estimating purely from the precision point of view. But there is always trade-off between the precision you want to achieve and what is the resource you are having in terms of money or time or trained persons also. So you will have to have a kind of a balance between these two. So there are formulas which are again available. What is the best sample size I can go if for a fixed cost? So this is kind of things which people use. But again, you need to know, or you need to have an idea that per unit sampling, what is the cost of collecting information per unit. So based on that one only, you will be estimating the resources required, or if this resources is required, whether it can be achieved within that resources. So that is what people will be trying to do. But many times it's a kind of a trade-off between these things, and then based on their past knowledge, people try to use them. So the way out is conduct some kind of pilot survey or look for the previous surveys, use those, or if you have multi-characteristic survey, then identify the most important one which are to be estimated. Now, the last point which I wanted to emphasize is that many times people do not realize that when you collect the data, survey data, if you are going to use it for descriptive purpose, that is what NSSO does. They just provide you the estimates at country level or district level or whatever level. So they stop at that time. But people use these data for some kind of inferential purpose. Maybe they want to run a test of significance, or they want to run a regression and other things. But the problem is when you go for inferential, then, and you are using a survey data, then there are certain issues. The reason is that if you have studied regression or any other, the typical assumptions will be the observations are independent, the observations are distributed identically. So both these assumptions are typically violated. For example, as I told you, that without replacement will be always used. So if you are going for a without replacement selection scheme, your observations are not independent. So because if a unit is selected at first draw, it cannot be selected in the subsequent draw. The last point is, again, if you go for a stratification, then all observations are not identical, because within each stratum, all observations are identical, but across all, if you ignore the stratification, the identity is lost, identical assumption is lost. So if you are going to use survey data for fitting a regression model or anything, then what is going to happen is, if you say, for example, I collected a regression, say some data, and I go and run it in SPSS or any other software. Say I want to run a regression, so I go and run it as a regression. So in that case, what is going to happen is that if you are going there, it is considered to be whatever may be your selection method, you are putting your data as if it is generated from the worst possible sampling design you can think of, that is simple random sampling with replacement. So all your sampling method are usually provide better estimate than simple random sampling with replacement. So what is going to happen is that all the standard errors could be more than the actual standard error. So that means your standard errors are more, means you will have wider confidence interval, and the test will be showing you non-significant. So the selected models again may not be best. So the way out is that typically in many software, you have a separate procedures for these survey data analysis. For example, there is something called survey regression, survey test. All these things are available. So those procedures or those software will take care of these issues. This is required when you want to go for the survey data, I mean inferential analysis of survey data. So let me stop here, and thank you, and let me I leave it to the organizer now.
Do you want to take break for 2 minutes?
Yeah, no issue. You can start telling me the questions so I can.
Yes, sir. Oh.
Yeah, go ahead. If you want, you can share with me the YouTube link so I can read it from another screen. That's also
yes, sir. That's okay, sir. So there are many other chats also going on. That's why it is very difficult to extract the question.
Sure.
Okay. So you said in the morning that like you have given an example of hill area. If you are going for surveying in hilly area, you do not want your sample to be far away from the place. So like you have selected your sample which is nearer to you. So don't you think it is also a part of purposive sampling, where you are deciding that it should be convenient for you to?
I did not tell that. If you have these, then I can think of a different, instead of going for a simple random sampling, right? Because a simple random sampling may result in villages which will be far away, which will be distributed across maybe one side of the mountain, another side of the mountain. So you will end up in, I mean, it will take more
Cluster
time
sampling.
for. So you go for a cluster sampling. So you group these villages. Those which are nearby, you group them as a single one cluster, and you select these clusters. So you will be
and then go for
more,
simple random sampling.
then it is a cluster sampling, it is called. So
Okay.
you have 50, so suppose 100 clusters are there. This I have divided into, say, 60 clusters of various sizes. Right. So
Okay.
in that 60 clusters, I will be selecting few clusters, maybe 5 clusters or 6 clusters or something like that. So that
And so that will be based on what? Selection of clusters?
That is random. That will be
That
random.
will again be random, then that cluster can belong to a further area.
No, you are, see, when you are doing a clustering, you will be doing a clustering of nearby villages. Nearby villages. Depending on the geographical proximity, you can, cluster formation is in your hand. Forming of cluster is in your hand. But which clusters you will select is through random process.
Okay, sir.
Right. So the formation of cluster is in your hand. So it is typically with the geographical proximity, you will form the clusters. Right.
Okay, sir.
But which cluster you will select will be through a random process.
Okay, sir. Okay. So it's a two-stage process then.
Yeah.
Yeah. So another question is how to do unequal probability sampling. Right? And what are the auxiliary variables that you talked about? Means
see, I was showing you, maybe let me just show you one Excel screen, and then I will show you how we can go for a stratification. See, for example, when you want to go for an unequal probability sampling, then what happens is that you need to assign different probability. So the one way is, for example, this is, so I want to select district. These are the districts in UP. I was using it for some other purpose, in some other training, I was using this. So these are the districts of, I hope it is visible.
Yes, it is visible. You can zoom it a bit.
Yeah, 1 minute. Just a minute. It is visible now?
It is visible.
Okay, 1 minute, just a minute. So these are my districts. These are my districts. Right. Now, I have several variables. These are area under different crops. So for example, I want to select based on their, let us say, the net area zone. Right. So if the net area zone is more, then they are agriculturally important. Right. So the one way is, for example, so this is my net area. This is my net area. So I can use it as an auxiliary variable. So I want to assign higher probability for those districts having more net area. You can do it for any of these, but I have chosen these. So what we are going to do is, for example, I have calculated here. So it is simply area of net area of that particular district divided by the total net area of the entire state. So it is a probability. So now if you see here, these are the unequal probability.
Yes, sir.
Now I can select these based on this probability. I can select it. Now the advantage of this is that suppose the characteristic which I'm trying to measure is very closely related to net area, like for example, asset or anything, something which if you feel that it is going to have high correlation with whatever I'm trying to measure, then this will give you a better precision. Same way, I can also stratify it based on, for example, say if the net area is less than certain one, I can put it in one strata. Between net area is between this to this, I can put it in another strata, and so on. So I can have a stratification, I can have a probability of selection using unequal probability. So this is how you have to do it. So auxiliary variables are something which is available. See, I need this variable, net area, right? If this variable is not available, I cannot calculate it. So the auxiliary variable should be available for the entire population.
Okay.
So since district is my unit, so I need auxiliary variable net area for the district one. So if I want to select villages using unequal probability, then I need the area of total area, net area of that particular villages, which may not be available. So if you want to go for an unequal probability, then you need an auxiliary variable, and that should be available for all the unit in your population, or at least in the stage in which you want to apply it. Of course, the selection procedure are little bit more complex because there is only one procedure which is available called SAM4. If you want to select more than 2 units, if you want to select, then it is very difficult. Only one procedure is available, and they are again computationally intensive. High computation is required. Without use of software, you cannot do it. The probability you can find out, there is no issue, but the actual selection and the estimation, all these things require a use of computers. Without that, you cannot do it. Okay.
Okay, sir. Okay. And so one question is on probability proportionate to size. How to determine that probability? Means we calculate the sample based on the size of the area.
See, PPS, yeah, the size is here. It is the net area used. Net area is the size. So that is so when I calculated this probability, that is probability proportional to net area. That is what we say, probability proportional to size.
Okay.
So that is the one.
Okay. Sir, is there any difference between cluster sampling and stratified sampling?
Okay. See, in stratification is division of the entire population. Division, right? And stratification, within the stratification, all the units will be selected randomly, right? In a cluster sampling, what happens is you are forming some groups. Say, for example, let us say there are, say, in a big apartment complex, you can say a gated community or something like that, it is there. So I can treat, say, the continuous 3 houses as one cluster, 3 or 4 houses as one cluster. So like that, I can form clusters, right? So these 4 cluster, I'm considering it as one unit. Another 4 cluster, I can consider it as another unit. Like that, I'm considering it. So now I will be selecting few clusters from the total number of clusters I'm having. Right. Once I select one particular cluster, all units within that cluster is automatically selected. But in stratification, what happens is that from each stratum, you will be selecting certain unit, certain number of unit. You will not be selecting all units in that stratum. You will be selecting only certain unit, and from each stratum, you will be collecting. You will be selecting. From each stratum, you will be selecting. But in cluster, it is not necessary that you will be selecting from all clusters. Only a a particular cluster, I mean, a sample of clusters only you will be selecting.
Yes, sir.
Okay.
Fine, sir. So you have just told us about the calculation of sample size with the help of the R package. So is it possible to do it in Excel also, because our students are from master's background?
It is usually then you need the formula. For simple random sampling, I have given.
Okay.
But in case of other sampling designs, then the formulas will be much more complex.
And that can be done in Excel too, with the by using formula only.
Formula, yeah. It is basically a formula is available, right? Even for example, stratification sample size for each stratum you want to find out, you will have to do it with, for each stratum you will have to provide these values and it is going to give you. Stratification, it is easy, but for other sampling designs, it is going to be a bit tougher. So that is why we say that you go for the packages. So this same function, you can use it even if somebody is not knowing about R. You can find out, run R code online like that. If they search, there are certain places where you can run the R codes. So it's the same formula, you can put it and execute it because you don't require any data. So if you are going for analysis, some analysis and all, then you need to know how to give your data to that package and all. Here nothing is there. Here you are just calling that function with those values. So you whatever is there in the slide, they can use that and change the value as per the requirement.
Okay, sir. So these were the questions asked by, there are a set of questions that was mine, and participants have also asked. Sir, one last question is that can you suggest some books which are really good for fundamental research methodology for social sciences?
The problem is that instead of looking for a book, they can try, I think in FAO this one is there. Manuals are there, how to conduct a survey and all. Because typically what happens is there are large number of books are there, but they are not meant for non-statisticians. It is meant for mainly for those who practice statistics. There is one, let me see that name, just let me find out what is that. Yeah, that is by Valiant. Let me share it. This is one good book. Basically, the function is available from this book only. That ncont, I was using it. That is from this only. This is somewhat easier book, but only problem is that it is meant for those who are involved in, not for those who are going for the first time survey. It is meant for somebody who knows all about sample survey, and then they want to do it. The only advantage is that they are having, typically they are taking it through an example problem and then how they decide about all these things. It is not, it will not give you anything on different sampling method and all these things, but it gives you so many things, but it will be slightly advanced because it is about executing a large scale survey. So
Okay.
there are so many issues are there when you go for a large scale survey.
Okay. Okay. Thank you so much, sir. So this lecture was really very, very informative for us. We learned a lot of new things here.
Okay.
Thank you. Thank you so much, sir. We are glad that we have invited you in this session.
Okay. Thank you.
Thank
very
you.
much.
Thank you so much, sir.
Right. So
for the participants, yeah. Okay, sir. For the participants, we have a lecture on scaling techniques tomorrow at 10 a.m. and at 3 p.m. by Meenasi Patel ma'am. So be there and attend and join. Thank you.